A few years back I worked with a group of apprentices and we made these lock gates. Look at the size of them. 12 by 12 green oak, that's about the biggest timber I've ever worked with in my lifetime. We even needed a block and tackle to shift each piece. Just think about these lock gates, they've got to hold the weight of all the water when this lock's full. Terrific weight, they've got to be really strong. Let's look at the construction. Well, I said the gates had to be strong to hold back all this water. Now what makes them strong? Mortises and tenons. If you look down the gate, all these rails are tenoned into the stile. The top beam is tenoned into the stile. If you stop and think about it, the mortise and tenons are a very ubiquitous joint. We find it everywhere. If you look at your door frame, your door, your window, the sashes, tables, chairs, just around the room you're sitting in, there's dozens of mortises and tenons. Let's go back to the workshop and see how they're made. I know what you're thinking, mortises and tenons, cut them by machine. Well, you can, and if you've got a lot to do, probably that's the best way. But in most small workshops we're not into mass production. If you think of the average frame or anything like that, it's only got 4 mortises and tenons in it the same size. It would be quicker to do them by hand than to set up machinery to do it. And what's more, if you're going to set up machinery to cut mortises and tenons, you've got to understand the joint properly. And the way to really understand it properly is to be able to make it by hand. Let me show you. Well, if we're going to talk about mortise and tenons, let's have a look at one. There we've got the mortise, a through mortise right through the job, and there's the tenon. Used to be called the tenant because it lived in the mortise like that. There we go. Now it's nice and tight, nice fit right through. As you can see here, now this is a straightforward mortise and tenon, through mortise and tenon, just like we've seen. But you will see that I've actually cut right through the job. Don't worry about the drawball pin, we'll talk about him later on. But you can see that the tenon fits the mortise all the way through the job. In other words, we haven't cheated by making a belly-shaped mortise. It fits all the way through, not just at the start and the finish. How do we manage that? We work super accurately. Now, that word super accurately might have frightened you, but you shouldn't be, because if you follow what I'm going to explain, you too will work super accurately. Now that starts right back at the beginning of the job when we prepare the wood. You know, we prepare the face side absolutely flat and straight and out of wind, and we mark it because that's going to be a datum right through the job. And then we plane the edge at 90 degrees to the face side and out of wind, and we mark the face edge like so. And then we plane the job to the required thickness throughout its length, and the required breadth throughout its length. And that is an accurate piece of wood. It's dead straight, it's out of twist and wind, and it's perfect. Now, if that is difficult for you, you need to look at our video number 1 on planes and planing, because it explains that in minute detail. Okay, so now we're going to set the job out. And the tools we use for setting out obviously have a bearing on the accuracy. So let's just look at the pencil to start with. The common or garden pencil. You might think any pencil would do, but it won't. What we want is a reasonably hard pencil so the lead doesn't crumble. A 2H is ideal, but it needs sharpening slightly different to the type of pencil we would use for drawing. What we do, in effect, we sharpen it chisel shape. We take a lump off of one side flat like so, we turn it 180 degrees and we take a bit off the other side, and then the other two at 90s we just take a small shaving, and we end up with a pencil tip like that. But we haven't finished. We need it sharp, just like our tools. So we use a piece of garnet paper and we rub the lead flat from both sides where we took the large shavings, and we've now got a chisel shaped 2H pencil. Now that's going to put us a very, very fine line on, and because it's chisel shape, we've got a long edge to the lead which will last much longer than a sharp point would. Well, that's fine for the pencil, but if we're going to cut the wood, we might as well have a nice sharp cut line. Now the tool we use to make that cut line has quite a bearing on its accuracy. If we took the normal tool that's sold to us in the tool shop as a marking out knife, it is thick. It's sharpened from both sides. We have trouble keeping this against the edge of the square or straight edge that we're marking with. And not only that, if it's a joiner's marking out tool like this, where we've got a scriber on the same tool, just look, we're marking down here, we get nice and close to see what we're doing, and we've got a sharp point right by our eye. We don't want that. So we don't want a tool like that. Okay, so the chances are you've already got a fairly decent knife in your workshop. The old Stanley knife, you know this. Why not use that? Well, unfortunately the blade is a bit flexible, and if we hit a bit of hardwood or a knot, the blade's going to deflect and we haven't got an accurate line. I find the best tool, in actual fact, I make myself. This is just an old piece of hacksaw blade. It's been ground to this shape. I've sharpened it at this pointed angle on one side only. Now that gives me a left and right hand marking knife. In other words, I can mark against the square that way with the flat against the square, or I can turn the square over if I'm marking the other way, turn the knife round and the flat is against the square again. So a left and right handed knife. Now last but not least is the square. You will have noticed that I'm using an engineer's square. Most woodworkers have a tool like this. Unfortunately, they're reputedly inaccurate. They get dropped on the floor and things, they go out of accuracy very quick. Engineer's square is a little more robust, and what's more, it doesn't cost much more. They come from little tiddly things like this to go at big chaps like that. And what's more, they're made to a British standard. Now then, we come to setting out. Now before we can set out, we need to decide on the width of the mortise. So what we're looking at in actual fact is this width here. How do we decide on that? Well, that is usually, on a straightforward square job like this, we say it's a third the width of the wood. Well, of course chisels don't come that accurate, So we tend to give the chisel the benefit of the doubt. In other words, if you've got a chisel a bit wider and a bit narrower than a third, you go for the wider one. The chisel gets the benefit of the doubt. Now, you need the chisel, there we go, and you'll see that the chisel is a nice tight fit on the mortise. In other words, that chisel's done all the chopping, there's been nothing pared off the sides of the mortise. This is an ordinary firmer chisel, general purpose tool in the workshop. Certainly you can chop mortises with it. This is the lightest of the mortise chisels. It's a sash mortise chisel. The blade is buttressed and it's got a tang, a little leather washer. But you'll notice that the blade gets narrower as it comes up towards the ferrule. This is to give it clearance in the mortise. Unfortunately, what happens as we sharpen this away and wear the chisel, obviously it gets narrower. There is a heavier chisel known as the joiner's mortise chisel, and you'll see this has got a big flat seating here because the joiner has to give it a lot of welly, and this gets the blows down through to the tip of the chisel. So there we go. There is a heavier mortise chisel than this, known as the socket mortise chisel, but I have no need of one of those. These days I tend to favour the Japanese mortise chisel, which looks entirely different, and it works entirely different. One of the main differences is these sides of the chisel are hollow, and that gives us sort of a sharpish edge up the corners of the chisel. And this clears the mortise, it clears the sides of the mortise as we chop it. And added to that, we've got that Japanese feature, which is in all their edge tools. We've got this very, very hard piece of steel laminated onto a soft, shock-absorbing steel back. So there we are, that's the chisel we're going to use. Let's get these others out the way. Now, we need to set up the mortise gauge to the chisel. We never take a measurement. In other words, this is never set to a rule. It's always set to the chisel, because chisels do tend to vary in width. They're never very accurate, and particularly the sort that wear away while we use them. So we adjust these pins to the exact width of the chisel. And when we've got them right, there we are. That's the pins of the gauge set up. We'll set the mortise out first. You'll notice I've got two different colour bits of wood so that we can see exactly what's happening. It's important that when we use the square to mark on here, that the stock of the square, this part, always goes against one of the datum faces. In other words, that is correct because the stock is against the face edge. If it's against the back edge, that is incorrect. So it's always against that face or that face. Well, we're going to mortise this piece of wood into that piece of wood like so. Doesn't really matter where we put the mortise. Let's put it roughly in the middle. So we mark one side of the mortise. Here's our chisel-like pencil against, and you can see we've got a really nice fine line. We now need to mark the actual width of the mortise. There we go. And again, with the stock of the square against the face. There we go. Square them over, because we want that onto the back. The mortise is going right through the job, so we need it marked on the front and the back. Again, you'll notice the stock of the square against the face side. So that's the mortise marked, or the length of the mortise marked out front and back. Now we've got to mark the tenon. We'd like a little bit of waste sticking through the wood afterwards for cleaning off, so we mark the length of the tenon. Now we're going to cut this, we're going to put a saw cut there. So we might as well have a nice sharp cut line. Now a cut line is nice and accurate for two reasons. One, our tools can find the cut, which you'll see later on. And the other one is, when we're squaring round, what we can do, we can put the knife in the cut we've just made. The knife has now dropped actually into the cut, and we can push the square up to the knife. We don't have to rely on our eyes lining things up perfectly. And we do the same again round the job. The knife goes into the cut line, up comes the square. Then last of all, remember, stock of the square goes against the face always, never the back. Find the knife and across. Now, what we're very interested in is that we've ended up with our cut line against the cut line we started with. If that isn't perfectly aligned, then something's gone wrong. Either the square's out of square or the wood wasn't straight. Well, now we're ready to set the mortise gauge up. And we need to put the mortise roughly in the middle of the wood. Now the easiest way to do that is to put the pins optically in the centre, as near the centre as we can judge. And then we just make a couple of little indentations, turn the wood 180 degrees, make two more, and then just set the gauge up between the two. And there we are. That's as near the middle as it matters. Now we're ready to gauge this mortise. Now the last thing we want is deep gauge marks on the face of the work where it shows, and we need to stop the marks exactly on the boundary lines of the mortise. Now the problem is that when we gauge these, we can't actually see the pins. They're hidden by the stem of the gauge. So what we've got to do, we put two little indentations. We can tip the gauge so we can see the line and see the pins, and we put two little indentations on the line, like so. Now, when we gauge, we will hear the pins drop into that. There they are, little click, and we turn the wood over, and we do exactly the same again. Two little indentations, gauge the line, click. So there's our mortise gauged. Now we need to gauge the tenon. So we have to gauge. Remember, the stock of the gauge goes against the face always. And there we are. Down the end grain and on the back side. So there's our tenon. Now we're ready to actually chop our mortise. There's two ways of holding this while we chop it. One of them is in the vise. Make sure it goes down well into the vise so that it's really gripped, because you're going to give it some stick in a minute and you don't want it to move. Take your mortise chisel and stand in line with the job. Don't stand beside it. What we want is to be able to see the chisel so that it's vertical, and we can judge that it's vertical. And then when you're quite happy, away you can go. Now, you're going to have to really wallop this chisel, and those bangs don't do the vise a lot of good. So a lot of woodworkers don't like mortising in the vise because they're frightened of damaging an expensive bit of gear. One of the best places to mortise is right up over the tail leg of the bench. Now we need to hold that there while we work. Probably the best tool to use is a straight clamp. There we are. Now when it was in the vise, it was supported on the sides and the wood couldn't split. It was holding the wood. Because mortises are usually near the end of the wood, we usually put a hand screw on just to support the wood and stop it splitting. There we go. Now we're ready to start chopping. Now this time we're going to use our Japanese chisel, but if it was a Western chisel we would have to drive it with a mallet. We certainly wouldn't take a hammer to it. There's two types of mallet we could use. There's the pattern maker's mallet, which is a wooden insert in a cast head, and there is the old joiner's mallet, which we make for ourselves, of course. It's a piece of elm. It's been soaked in linseed oil, so it's really nice and heavy. You only have to lift it up, it comes down on its own. There's a little secret about this tool. The cabinet makers in the old days, when they used to have to be journeymen for 4 years, needed a bit of money to take about with them, and there weren't any banks, and they certainly didn't have a credit card. So what they done, they drilled a little hole in the mallet handle and they put their sovereigns in the head. So there you are. That's another trade secret blown. Well, there we are. So we're ready to chop this mortise. But we're going to commit the immortal sin, in actual fact, in woodworking parlances. We're going to strike this chisel with a hammer, but it's a Japanese hammer and it's made to hit the Japanese chisel. We start the cut about 1/8 of an inch back from the end line. Now when you're driving this chisel, it doesn't want a few little taps, it wants something that's really doing some work. So we start coming back along the mortise like so, a couple of good bangs each time, and because the chisel's got the slope my side, it's going forward and it's forcing the chips out. When we get towards this end of the mortise, we can turn the chisel round like so, and we begin to come back towards the line. We don't come right up to the end of the mortise. We stay clear by at least 1/8 of an inch, because then what we can do, we can lever chips out. And of course we've got the same the other end. We pass backwards and forwards along the mortise, treating it exactly the same. It's a nice hard bit of black walnut. Cuts fairly clean. When we consider we're halfway through, we can turn the job over. We're not quite there yet. And what we're going to do, we're going to clean those chips out before we turn over. This is exactly the same as last time. Well, there we are, we're right through. All that remains now is to clean the bits out. Now we're left with the 2 little 1/8 of an inch that we left either end of the mortise. And what we do now, we put the job on a chopping board so we don't damage the surface of the bench. We take a nice sharp chisel, about the same width as the mortise, and we pare these ends back. Now it's important that this is a nice straight cut from one side to the other. Don't forget, this is the edge of the tenon bears against this, and part of the strength of the joint is in that surface fitting perfect. You can of course chop down with a mortise chisel either end, but it's nowhere near as accurate as paring like this. So there we are from one side. We just tied it up from the back. And the other end of the mortise just back nicely onto the pencil line. Nice straight cut right through. And then last of all, you can actually hold the job up, hold the flat of your chisel through, and you can see if you've got a bump. We've got a little bit of a bump in the middle there, look, and we want that nice and straight, so we'll just take that off. Do a final check. There we are, beautiful. So that's the mortise. Now we said just now that we could chop on the bench top in the vise and on the tail, but if you stop and think, as wood gets fairly wide, and particularly if we're using a big Western mortise chisel, we're getting up in the air and we find ourselves working on tiptoe. There's a little appliance that we make in the workshop, and it's called a mortising stool. And we can put the work on the stool, like so, and then we can sit on it. Now in the old days, you used to get the sack if you sat down, but of course if you could sit down and work, there was an excuse. So the mortising stool was quite a use. So you can really work in comfort, and that's how you'd use the mortising stool on big work. Well, there we are, that's mortising. Now we come to the other half of the joint, the tenon. You remember we set that out a bit earlier on. Now we've got to cut it. The first job is to actually run the cheeks in. We call this running in. That's sawing down the grain either side of the tenon. It goes in the vise at about 45 degrees to start with. But you might have trouble seeing those fine cut lines that we made with the gauge. But if you take the pencil, do you remember the pencil was sharpened like a chisel? You'll find that it will run in the cut lines and make them stand out. There we are, you can really, now you can see your cut lines. This is quite important when you're getting old like me, your eyesight goes. There we are. So we're in the vise and we're ready to saw down these tenon cheeks. Now there is an important thing to remember here, a very important thing. We'll just make a start. It's a very hard old bit of rock maple, this is. If you look at the saw cut that I'm making, you will see that it's in the offcut. In other words, it's in the waste piece of wood that we're going to cut off, so that the tenon will remain its full width. So all our sawing must be in that waste side. At no point must we encroach onto the tenon itself. And when we've sawed down to the shoulder line, our cut shoulder line down here, and out to that point there, we can come over and we can saw the other tenon cheek. Don't forget, we saw in the waste. So there we are. That's half of it done. Now for the other way, we put it back in the vise, but this time we put it in there vertically. There we are. And we saw down again. Remembering to stay in the waist. And what we must watch and be very, very careful that we stop just on the shoulder line or just proud of it. The last thing of all is not to go past the shoulder line, or otherwise those saw cuts are going to show on the finished work. So both sides, right the way down. Little tip in actual fact, if you're having trouble and the saw seems to be binding a bit, particularly in very hard dry wood, take your oil wick and you can just lubricate the sides of the saw. Ah, see how that's running much better. There we are. So we're down. That's called running in. We've run the tenon cheeks in. Now we're ready to cut these shoulders. And we do that on our bench hook. Now some people, and it is difficult, have trouble starting the saw and keeping right spot on this little fine cut line we've put in. Now I'll give you a little tip. It's quite a good idea in actual fact to make that cut line a little deeper. Remember, if you're going to put a square up to a cut line, put the knife in the cut line and push the square to the knife. Now if we make that deep by giving it 2 or 3 strokes across there, we can take a chisel and we can remove that piece of wood. Now that's giving us a step. That in actual fact has given me a little step, look, right across that shoulder line, and we need that to be nice and clean. There we are. Now that's given me that hard corner to put the actual tenon saw against to start it. So now it's got to be sawing to that line. Don't forget we're sawing in the waist still. Now one of the things to watch here is to stop the saw when we get to the tenon cheek. It's very, very easy to score into that cheek, and if you do, that's a very, very weak point. The tenon is likely to break off in the job. There we are. Now we've got to do exactly the same on the other side. So turn it over. Don't forget the stock of the square goes on the face edge. Two or 3 strokes. Take a little bit off in the waist. There we are. It's worthwhile doing that actually. It makes things a lot easier. Taking care to try and saw square to the line, right down to the tenon cheek, and stopping. There we are. You can actually hear the sound of the saw changes very slightly as you get there. There we are. Now we've got this dirty little corner in here where the 2 saw cuts met, and it's important that we clean that up because that'll stop the joint fitting perfectly. So if we take that off, same the other side. I've enjoyed making joints all my working life, and I'm a little bit impatient to get to the point where you put them together to see if they fit. Of course they don't always, do they? There we are, we've come to the moment of truth. Will it go together? So here we go. Yeah, there we are. We've got a reasonable fit. A through mortise. Now when we started we looked at a through mortise as well. But things are not that simple. Here we've got a joint, a mortise and tenon. But you see it's got an overload moulding. And it's also got a rebate on the back. So you could say this would be the glass rebate in a sash. We cut the horn off, of course, and this is the inside overload moulding showing to London. So you see we've had to accommodate a rebate and a moulding. We've scribed this shoulder to fit over the moulding, and this shoulder is long enough to go down and fit in the rebate. When we make a mortise and tenon that's on the end of a piece of wood, in other words this is eventually going to be cut off here, it would just fall out. So we make the tenon only part of the width of the wood. Normally we say that this amount here, the ratio of that to the width of the wood is 5/9, little over half. So the width of the tenon is a little over half the width of the wood. We've made this part fit over here, over the width of the wood. This is called a franking. When we put mortise and tenons together, we have to hold them in some way. In other words, we don't just rely on glue. This would be wedged. So we would drive a wedge in either end of the tenon, and we need wedges the exact width of the tenon. So what better place to cut those wedges from than that waste piece of tenon there. So when we cut this out, we actually saw our wedges out, and we have two wedges that later on we will glue and drive in either side of the tenon. This will hold the joint together. On some work, particularly heavy work, frames and so on, we put a pin through here, a drawbore pin, to hold the job together. On a wide one we might put two. We call this a drawbore because what we do in effect, we use the pin not only to hold the job together but to draw it up tight. So what we do, we bore a hole normally slightly farther away from the shoulder. There we are. Be rather careful when we break through into the mortise that we don't do too much. And we go the other half, and the bit will stop pulling the minute it goes out the other side. We turn it over and bore back. Now that's our hole through the mortise. We need just to clean the whiskers off the inside where the bit broke through. Now if we put the job together, there we are, we can put the brace bit back in the same hole, and instead of turning it in a boring direction, we turn it backwards. We've now got a mark on the tenon, which is the centre of that hole. What we need to do in actual fact, we need to move that hole very, very slightly. And if you think about it, we need to move it towards there and there. So if this was a job, in actual fact, we try and keep it tight into the face edges and pull the shoulder up tight. And to remember this, we have a little rhyme, and we say, to the shoulder from the face brings the joint up into place. There we are. We need to make that hole now. There we go. Again, be careful. The bit will draw itself, you don't need any weight, and it will stop as soon as the little screw has come through the other side. We turn it over, go back. That's our hole. And now you can see, if you look in here, the actual hole in the tenon is slightly out of line with the hole in the mortise. That means that when we bang a pin in there, it's going to pull this that way, and it's also going to keep it forced in to the face. Now, you've probably seen these things that you think are butcher's steels. They're not. They're joiner's drawbar pins. When a joiner's fitting a big frame together, or a staircase where the strings go into the newels, he can push this in to the hole, and you will see that it's pulled the shoulder up nice and tight. So if we had half a dozen rails going into a stile, we could pull them all up and we'd sight them through for wind. Now, a lot of people would cut a bit of dowel off and bang it in there, but we never use dowel. Dowel is notorious for being short grained, and the last thing you want is a bit of short grained wood in there. So we always make a pin. Now, this was a job that the youngest apprentice in the workshop got. He had to keep the pin box full of drawbar pins, and it was a horrible job. They're always split. In other words, we split the pin out of the wood. We want grain that runs the full length of the pin. We don't want any short grain at all. So in actual fact, we split the pin from solid wood, and you can see that the grain runs the full length of the pin. There we go. So we'll take a bit of this split wood and we'll make a pin. It's quite a quick job. Now, believe it or not, old Nelson ship Victory's literally held together with these things, and the shipbuilders call them tree nails when they're made out of wood. But like everything in the woodworking trade, we don't pronounce that properly, we call them trennels. So this in actual fact is a trennel, a tree pin, which makes a lot of sense, doesn't it? Seeing as it's made of wood and it's a pin. There we go. I'll show you something in a minute. Believe it or not, somewhere I've got a tree nail that came out of HMS Victory. Well, when we get it to that stage, rather depending on the job, we can do two things. We can either bang it in and let the soft wood take up the shape, or we can use a dowel plate. And a dowel plate is something with holes in. You'll see this one's actually stamped with the size of the hole, and the hole on the face of the plate is slightly smaller than the hole on the back of the plate. This gives us sort of a cutting edge, and it means that if we bang this piece of wood through there, we've actually cut the wood away, and we've got a nice rough dowel type pin. In other words, the grain still runs the full length, and we've got a 1/2 inch diameter pin which we can welt into the joint. Then then we now saw that off on both sides, a bit more there. And there we are. We've got a drawer board through mortise and tenon. Look how nice and tight it's pulled that shoulder up, both front and back. So there we are. And believe it or not, that is a piece of Art of Oak Trenel from HMS Victory. So that was banged into HMS Victory in about 1800. How about that? We're going to make another mortise and tenon, believe it or not. This time what we're going to do, we're going to make a mortise and tenon as though it was in the corner of a frame that's got a rebate in it that would hold glass or a panel. This means that one shoulder of the tenon's got to be longer to fit down in the rebate. And we'll use this piece of wood. We'll chop the mortise in one end, that would be the stile. We'll cut the tenon on the other end, which would be the rail, and then we'll cut the thing in half and fit them together. So our first job is to set out. I've already chosen a chisel. This time we'll use an ordinary Western mortise chisel, and I'll try and work in different positions on the bench, so maybe you'll see different features of my work. So the first thing we have to decide on is the actual size of the rebate. Okay, I know you haven't got a gauge like this. This is a one and only. It's a favourite little tool of mine, but it's quite important. So we're going to have the mortise roughly in the middle of the job. I say roughly because it doesn't really matter in this case a lot. So here we have the actual, this is the edge of the rebate. I'm gauging the edge of the rebate. I'll make it deeper. I'll gauge this deeper than I normally would so that it stands out and you can see it. So there we go, that's the rebate. Once again, we have to set the pins on the gauge to the chisel. Cool, that was a good guess, wasn't it? That will do us there. But I want the mortise and tenon now to fit against the rebate. So in actual fact, what I've got to do, I've got to set this gauge so one pin runs on the edge of the rebate. So there we are, that's our mortise gauge set up for marking the mortise and tenon. Now the next job is to mark the lines where the mortise and tenon comes. We need a rule and we need our pencil. And we're 1 inch and 13/16. We're going to need a little bit of waste below the rail. We want a little horn to cut off afterwards, so let's mark that first. And let's mark the top of the thing, so 1 inch and 13/16. There we are. Now if you remember, we said that when we looked at the franking joint, we said that the tenon made about 5/9, so a little over half for our 5/9 for the tenon, or the mortise, whichever you like to say, but that's the width of both. There we go. Now we want those, we're not interested in taking this line round, it's just the mortise line. So we square the mortise line round. So that's the mortise. Now we need to decide on how deep we're going to make the rabbet. And I should think this one we'll make 1/4 inch. So we set the gauge up to 1/4 inch. There we are. That's that. And we can now actually gauge the depth of the rebate there. That's great. Now we can set the tenon out. So the tenon wants to go right through the wood. So again, we want a bit through for clearing off afterwards, because we might wobble the saw when we start running the cheeks in. So let's say we come in just over 2 inches. Well, there we are. That'll do nicely. Again, we're going to use cut lines for this. If we put a line there, so, then we want to come forward of that on the other shoulder 1/4 inch to fit down into our 1/4 inch rebate. So the shoulder on the rebate side of the wood is now 1/4 inch longer than the shoulder on the back of the job. So we can square this shoulder down here, and I showed you that we needed a nice deep cut here because we're going to make a little step to start the tenon saw against. Do you remember? And we're going to do the same here. We're going to find the cut line, push the square against it, mark it across, and we need both of those over on the back of the wood. Now this time we can't square right round the job and see if they meet, because remember, one shoulder is longer than the other. So there is our setting out for the shoulders. That's great. Now we need to actually gauge the tenon. Don't forget to stock against the face. There we have the tenon. Now we do the mortise, but this time I actually start on the line. I don't have to find a stop point because I'm gauging into the waist. And because I'm going to cut a haunch in, and we'll talk about that later, I want a little mark on the end. And then I mark the tenon on the back, and it's here where, do you remember, we make the little click. There we are. That's the job set out. Now it's important that you have a system of work. In other words, there's certain things that you need to do in a certain order. We can chop the mortise and we can run the cheeks of the tenon in, but we must then work the rebate before we cut the shoulders, or otherwise there's nothing for the fence of the rebate plane to work against. So we'll start off by chopping this mortise, and this time I'm going to chop it in the vise. I'm going to move right back here. I'm going to use a Western chisel and a different technique so you can see the difference. Make sure the vise is done up well, because this can drive it all over this place. Exactly the same as before. We're making our first cut about 1/8 of an inch back from the end, and then we're moving forward, and you'll see that the actual work is beginning to slide down in the vise slightly in spite of all the strain I put on it. We're actually through, the chips are falling out. This is one of the advantages of actually chopping in the vise. So you pays your money and you takes your pick. Can you see how well the mortise chisel is actually fitting in the mortise? That is quite important. In other words, that's why we set the gauge up to the width of the chisel, and we've got a mortise that fits it exactly. So there we are. We're right through. with 1/8 of an inch either end. We're going to come up on the bench top and pair the ends through just like we did previously on that mortise in black walnut. So we'll put it on there and we'll find a chisel and we'll just pair these ends. Nice square ends at the end of the mortise, straight line right through. These little short mortises are rather difficult in actual fact. They don't give you much room to manipulate your tools in there. But it's certainly a lot easier working in this piece of mahogany than it was on the previous black walnut. Don't forget that we want this nice and straight right through from side to side. We don't want it bowed in or out. Well, that's the mortise. Now, what we've got to think about now is we've got a haunching. Now, a haunching is something like a little stub mortise and tenon. In other words, it doesn't go right through the wood, it just goes here. This is for two reasons. One, it stops the twist of the rail, and the other one, it stops any daylight shining through if it happens to be a window or something that's got an external surface outside. So we'll worry about the haunching in a moment. Let's run these tenons in. We need to put them in the vise the other end of the bench. We're doing this the other way on so that you get a different view this time. And there's a point I want to make in actual fact. Let me just start the saw first. Right. Now when we're sawing, we try and keep the saw, the hand, the elbow and my eye all in line. This helps us to saw straight and accurately. That's that one. I'll just check this one again. That'll do us fine. So there we are. We've now run the tenon cheeks in. Now if you remember, I said earlier on that the next job is to work the rebate, and we'll pop it on this end of the bench between the dogs like so, and here we go with an ordinary edge fillister. This is a repeat performance of the last time we cut some shoulders, so we make a little step there to start the saw against. There we go. Exactly the same. Be careful not to saw into the cheek of the tenon. Turn it over, and again. There we are. Just clean that nasty little corner out. There we are. And whilst we're about it, we might as well cut it in half, and then we're ready to mark the haunching out on the tenon. Well, there you are, 2 bits of wood from one. An old cabinet maker I used to work with called that multiplication by division. You think about it. Well, now we're ready to mark the haunching on the tenon. We'll just put that in there so you can get yourself orientated a bit. We're going to cut this out so it fits down. We need to pick up this width on the tenon, and we also need to mark the depth of the haunching. So to do that, we've got a different tool. Now these, if you've ever met a set of slip gauges that an engineer uses, well, these are sort of a wooden version. The cabinet maker normally makes these for his own use. Each one of these little pieces of wood is an absolute spot on thickness, and the thickness of the wood has been stamped on the side. There you go, look, 5/32. I happen to know that we want a 3/8 piece, so that's the 3/8 gauge. We need that in a minute. Now we need to mark the width of the tenon on there. So in actual fact, we're picking up the actual width of the tenon, this length here. We're picking that up onto the tenon we've just cut, and we need to just put a little tick mark there. Then we can take a gauge and we can set the gauge up to that mark. There we go, and we can mark that onto the tenon right the way round down there. We can take our 3/8 slip gauge that we had just now, and we can mark a pencil line against the gauge. So that's it. Now what I'm going to tell you to do is, when you first cut mortises and with haunchings, just mark that bit you're going to cut out, because believe it or not, the number of apprentices that I've seen have cut this bit away, and oh dear, look what's happened. So we're going to cut that part there away so this fits in, and we need some wedges to hold this job together. So what we're going to do, we're going to saw that out, and at the same time as we saw that away, we're going to saw some wedges. Now I haven't marked the wedges because from experience we know roughly how to cut. Now you never got enough wedges, so we'll have a couple of spare ones as well. There we go, and last but not least, the accurate cut down the side of the tenon. There we go. Back onto our bench hook. And we cut the wedges off here. Well, there we are. That's the wedges cut. Now those wedges eventually end up either side of the tenon like that, and it more or less forms a dovetail shaped tenon. So we're ready to fit the joint together, but first we need a little bit of room made for the wedges. Now with a softish wood, and I don't mean a soft wood, I mean a softish wood like this mahogany, you don't need a great deal of wedge room. But if it was oak, you'd need more or less a complete fit for the wedges, because the wood has got no give at all. Well, there we are, that's the wedge room. Let's just have a look, make sure things are going to go together. Well, that's not too bad. and we're ready to wedge it. So if we take it out the vise and we turn it over, we can put a wedge front and back. Now don't forget, this is the corner joint of a frame, and eventually this little bit of waste is going to be cut off. And it's important that this rail, if there's any slap in the tenon, is forced up against the shoulder line here, or otherwise we'll have the wrong size and we might be out of square. So it's the outside wedge is always driven first. There we go. And then this chap there, and we can just clean that up by sawing that waste away. There we go. So there's our mortise and tenon and a rebated joint. Now let's just get rid of these offcuts. We'll have that out of the way. Make a little bit of room, because what I want to show you now is where this joint actually comes into play. We've got 4 pieces of deal here. Now let's suppose that we're going to join these together to make ourselves a frame. So there we have. We've got a stile and a stile, a top rail and a bottom rail. You'll notice the orientation of the face and face edge marks. It's important that you have this system. Now, in a lot of work, this bottom rail might be wider than the top rail. So obviously the mortises will be of a different size. The stiles are handed. This is a left-hand stile and that is a right-hand stile. If you ended up making 2 left-hand stiles or 2 right-hand stiles, you wouldn't be able to put the job together. So we always work in pair. So when we're setting out, we put these 2 pieces together like this, and you've got the 2 V's pointing away from one another, and we call that in pair. The same thing happens with the rails. We put them in pair. That is one of the reasons that we mark the face edge with a V mark. Now, if we're going to set this out, suppose we had 3 doors all the same, there would be 6 stiles, and we'd be able to put them all side by side like this, and then we can pop a clamp across them and hold them together. And now we can put our lines, just at the moment arbitrary lines, but suppose that was the tenon. We've now marked 2 pieces out, or as many pieces as we've got, and we know when we do it with them clamped together, we know that those marks are identical distance apart on all our pieces of wood. But the main point I wanted to make was the fact that we work in pair. So there we have it. Don't forget the face marks and face edge marks. The face edge marks always point away from one another, and you'll find that cabinet makers and joiners, whenever they stack parts, they always stack them in pairs with the marks like so. Now, do you remember that joint we've just made? We said that it was probably the corner of a frame. In other words, it was sort of that part of a frame. This waste at the top would be cut away, and that would be the corner of a frame. Well, that's great, but quite often in cabinet work, the edge of a frame shows, and the last thing you're going to want is this end grain showing through. So that gives us another problem, and on some work we don't take the tenon right through the work. We stop it before it comes out the back. So the mortise doesn't go right through the wood. This is called a blind mortise, and there is a little bit of difficulty in cleaning the bottom of the mortise out. So let's look at that next. Well, there you are. I've chopped more or less to the full depth I want to go, and I know the depth because I've put a piece of masking tape round the chisel. Now we come to that sticky problem of cleaning the bottom of this mortise. We've got to get the chips out. Well, the old cabinet makers, because there wasn't a tool made for it, used a mortise chisel and took it to the blacksmith, and he bent it like this one. And that gave us something we could hook with, but it still wasn't very successful because, as you can see, it bashes the end of the mortise. Several firms made what we call a swan neck chisel. Don't get this confused with the door lock swan neck chisel. They're two different tools. And this works after a fashion, but you need a fairly long mortise for it to be much good, but it does sort of rake the chips out, as you can see. I prefer to use these Japanese tools. This is a harpoon chisel, and you drive it into the work like that. You hook it under the chips, and you can actually pull the chips straight out of the job, and you get a reasonably clean bottom. Having chopped this far, we no longer need the cramps, so we can take them off and put them out of the way. That means we can actually loosen the wood, and we can tip most of the rubbish out. But now we've got this problem of cleaning the bottom of the mortise. All our tools so far are chopped down into it, and we need something that cuts along, not down. So we have this Japanese tool. Now this is the ideal tool. I find it works very well. Like all the Japanese tools, it's hard and still shut onto the cutting edge there. The Japanese name for this tool, in actual fact, it translates as a bottom cleaning chisel. Now that's a bit mind-boggling, isn't it? So we can actually drag it along the bottom, like so, and it's almost like paring along the grain. It's a much easier tool to use than any of our Western tools, and what's more, it gives you this lovely finish to the bottom of the mortise, nice smooth finish. But one of the problems is with all blind jobs like this, where right in the bottom we need a real clean, precise bottom to this mortise. So we need to make sure that all these little dirty corners are cleaned out right down to the very bottom of the mortise. Don't, whatever you do, pare the side of the mortise. You want that as a perfect fit on the chisel, and then just tidy up the ends like so. Tip the chips out. There we are. Well, there you are. That's the blind mortise. Now the tenon that goes in there would probably be fox wedged, and immediately you think, oh good, he's going to show us fox wedging, I wonder what that is. Well, I ain't. I'm sorry to disappoint you, but the problem is that there's 101 different mortise and tenon joints, some of them designed just for one purpose, and I could go on in my workshop for a fortnight showing you different mortises and tenons, and you probably wouldn't derive much from that. You know, there's the diminished style door, which has got its gunstock shoulder. You've got rebates that die out and have splayed shoulders. You've got those funny little stub mortises and tenons in glazing bars where they join. You've got the tuss tenon that's used in construction work to join joists. And you've got the hammer-headed mortise and tenon that's used to join circular-headed doors onto straight stiles. We could go on and on and on, but what I've really tried to show you, and the whole idea of this, is the basic principles, these foundations. If we can get the mortise right and we can cut a tenon, then all these other joints develop from that. So this is really the foundation of mortises and tenoning, and if you can do this, well, it's not long before you can do the rest. And you won't have to resort to that funny little poem you hear in some cabinet shops. In skill and tools we put our trust, and what they won't do, well, putty must.